After I was done recording the conceptual videos, I realized I forgot to go over static equilibrium and how to solve problems associated with that. So, in this case, equilibrium just means that the system has no acceleration. So it might have a velocity or it might be at rest. So if it's at rest, we call that static equilibrium, and if it has a velocity, we call that dynamic equilibrium. I mean, in this case specifically, this can apply to all other types of sciences, like chemistry. You guys know what I'm talking about last year. Anyways, so basically, in static equilibrium, it's not moving, and the acceleration of the system is 0, which we will see applied in the question. So right here, I have this very poorly drawn system. So basically, there's a 50 kilogram mass being hung on 2 ropes that are at different angles from the surface at which they're being hung at. And we're going to solve for tension 1 and tension 2. So, in this case, the first thing you're going to want to draw is the free body diagram, which I will do here. And this is with inclines basically. I mean, it's not on a ramp or anything, but the tension, the rope is at an incline. So we obviously know that there is a gravitational force, and they literally give that to us. That is 50 newtons. And then we have tension 2, which is at 60 degrees. And then we have tension 1. I mean, I should have done that the other way around, but oh well. Which is at 45 degrees. And then we just need to break these down into the vector components. So we have the y component of 1, and then the x component of 1, and then the x component of 2, and the y component of 2. We know that there is no acceleration and that this entire thing stays at rest. So that means that, the forces in the y direction are going to balance each other out, and the forces in the y direction are going to balance each other out. So let's start with a simple one. In the x direction. So we can imply that t1 cosine of 45 degrees equals t2 cosine of 60 degrees. Because if they weren't equal to each other and cancel each other out, then there's going to be acceleration in the horizontal direction. And then it's the same thing for y. So both of these forces are pointing upwards, and they are balancing out the gravitational force. So we get that gravitational force, actually, I'm going to write that as 50 newtons equals t1 sine of 45 degrees plus t2 sine of 60 degrees. And now we have 2 equations and 2 unknowns. And guess what? You're going to use algebra. And I'm not going to do that on screen, but after you finish algebra, you're going to figure out that T1 equals 18.3 newtons and T2 equals 36.6 newtons. And that's how you do it that's how you do force questions if your system is at rest.